Hello and welcome to Golden Droplets episode number 31. My name is Ricardo Valls. I am the founder and president of vallsgeoconsultant. And in today's episode, we are continuing our mini-series of software to process data, geochemical data mostly. And today we're going to be looking at petrological software like Newpet, MAGMA, etc. So these are the software that can be used to process those results that we get from major elements and also trace elements. So once again, Golden Droplets episode 31. Enjoy! We will start looking at Petrograph, and you can download the software from here. I will put a link for the complete site. But before we can start working with the program, we need to prepare our data. And I'm going to be using a data set modified from New and Batista. Not only we changed it by the author of Petroplot, but also some changes that I added myself, like I added a gold column, changed the name of the samples, etc. In order to be able to use our data in Petrograph, we need to do the following. We need to add 3 columns to our data set. First column will be a column for symbols, the second one for colors, and the third one, the plot, will be 1 if we want to plot the data, or 0 if we don't want that data to be plotted. The symbols and colors are shown in this section here, and as always I will have all this information and support data on Mendeley, and I will put a link here so you will know from where you can download it. So now that our data is ready, we can save it as an XLS or as a CSV, and once we do that, we go and open Petrograph. We start by importing our CSV file. It usually takes a little time to upload. And here we have our data. All the major elements, all the trace elements, and column for the symbol, the color, and to plot or not plot. So let's hide this for now. And you have several options here. You can do your own graphics. For example, let's say you want a binary plot between silica and magnesium. You can change the dimensions here. You can do some operations. Let's say you want to have sodium plus potassium. And you click plot or the space bar, and you have here your binary plot with the silica here and the sum of alkalis here. If you right click on the map, you have many other options, like you can copy the graphic and paste it or save it. You can find the correlation. There is no correlations here. You can identify a sample in the graph, like you click here, and it shows where it is. You click that one, and it shows where it is. You can also do ternary diagrams. Let's say we want to do one with silica, aluminium, magnesium. Again, you can always do operations. Once you are ready, you can select the size of your diagram. You click here, and you have your ternary diagram. You can do a spider graph, like the RE, and for that you just click here on the magic wand, select Add All, and now you just click Plot, and you get your RE diagram. There are also mass balance calculations. You can do classification diagrams, etc. But the classification diagrams is the most important part. So we go here to plot diagrams, and you start always with a general classification. You see how many options you have here. Let's do middlemost. So most of your rocks are subalkalic and alkalic rocks. Let's do another one. Plot. Well, all the rocks are falling on the area of the mafic and ultramafic rocks. We know that these are volcanics, so we assume that these are basalts. So let's see, plot, diagram. Yeah, doloitic series, calc-alkaline series, and high potassium calc-alkaline series. So let's see the graphic for the basalts. Basalts, binary, let's start with Pierce. And most of the samples are in the field of D, which is morb, or B, which is morb 2, but are calc-alkaline. Another type. So you see, you can do different type of classifications plot here. Let's do a last one for basalts. And you get a perfect distribution here. This is one of the best ones. So we get most of our samples are classified are within plate, alkalic basalts, no E-type morb, some within plate oleite. As you can see, you can do as many graphics as you want. They have been numbered. You can always right click and copy the graphic or save it, etc. There are plenty more things that you can do with Petrograph. So I encourage you to download the program, install it, and first learn how to use it using the data set that I will provide on Mendeley, and then use your own data. So this is Petrograph. The first program that I used to process major oxide information and petrological data in general was Newpet, which was a freeware developed at the Memorial University of Newfoundland. It was a DOS-based system, was not very friendly, but it was extremely useful and very practical. Regrettably, the creator of this software stopped upgrading it, so now it is impossible to download from the internet, and even if you have the old software and you try to run it, usually give you an error message saying that it's not compatible. So if somebody out there knows about a way of solving this, please email me back, because a very good software. What I did is I could not use Newpet. I took all the graphics and system, etc., and went to Excel and I created my Newpet, which basically reproduces all the graphics in the same sequence as in Newpet. So we start with our data, and you have the major oxides, the trace elements. You don't have iron oxide total. The program will calculate this for you. So the diagram that you have is silica versus potassium, and it basically differentiates the oceanic plate from the rest. Then you have the silica versus aluminum, and you get the different, this is an inland arc, etc. And this is the graphic. You have a series here of silica versus iron total plus magnesium. Okay, so this is where you get it. You have the chance index, which is to find metaluminous and peraluminous, and you have the silica versus titanium. These are all the basic graphics, and then you have a final with all the figures joined together. So and it is free to modify. If you want to add more graphics, please feel free to do so, and also please share with me. So this is my Newpet. Another software that I use for petrographical studies is MAGMA, that can be downloaded from here. And it's a very interesting application that will tell you a lot of information about your sample based on the geochemical composition. So after you install it, let us see how it works. So I have here the same data file. I click on MAGMA, and then I will just enter the information on each of these things. So after each number, I just press enter. I only have the total iron. I don't have it divided by Fe2O3 or FeO, but I write it all as if this was Fe2O3. So total. And then I leave the other one 0. The program will estimate the value of FeO. Magnesium 0.15. So manganese 0.15, magnesium 9.35, calcium 1276, sodium 2.29, potassium 0.04, 5.13. We don't have information of the water or nothing, but that's it. We are ready to do our calculations, and for that you just click calculate, and the machine is asking what is the ratio for converting the FO2O3 into the two type of iron, which is usually 0.41. We click OK, and we get all the results. We have the mineralogical composition of the rock. We have the temperature, the pressure, and we have a lot of information about the basic mineral phase. The chance classification is a metaluminous silica saturate. This is a gabbro. The texture is probably a phanitic. The liquid temperature 1208, and you of course can print all this. You can see a dust plot, so you see where it falls. And okay, you can print this or save it. And you can save the results, you can print the results, and that's it. You go to your next sample. The only problem with this application is that you cannot enter more than one sample at a time. But it's a very useful tool, and I strongly recommend you use it. It's very, very simple. The program also has some examples, like for example here, for a basalt, you calculate and you get different things. You can say that is a monzonite. This is an example. You can calculate and you get your composition, different data that you will use. So that is MAGMA. Before finishing, I would like to show you some Excel macros that will allow you to do certain petrographical. This one here, for example, is a conversion table that will help you convert element to oxide or oxide to elements, which is very useful when doing petrological studies. This one here is a little bit more complicated. It's a CIPW norm calculation. You just enter your geochemical information for the major elements, and it will give you the norm calculation and the possible type of mineral composition. This is another version of conversion element to oxide or ppm to oxides. And this one here will use the geochemical data to do mode estimation with some graphics too. All this software you will find on Mendeley, and I'm putting here a link, together with all the support materials, the data that we use for these examples, and the user guides or manuals for many of these software. So with this, I will end Golden Droplets episode number 31. As always, wishing you all good health, both physically and mentally. Until next time.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell